Hello, welcome to my presentation. My name is Abdul-Majeed Mahamadu. I'm a senior lecturer at the University of the West of England in the Department of Architecture and the Built Environment. The paper I'm going to be presenting to you today is entitled I Spy with My Little Eye, Improving User Involvement in Elderly Care Facility Design Through Virtual Reality. I'm going to be presenting on behalf of my other co-authors, Dr. Udona Okeke, Abinesh Prabhakaran, Colin Booth, and Professor Paul Olomolai. As an overview, I'll be giving you a background to the research that led to the development of this paper, as well as the methodology we employed, the key findings of the study, and some of the conclusions that we have drawn. In terms of a background to the research, statistics indicate that there are a lot more older people living in the population. And from the ONS statistics, by the year 2020, there'll be more people living over the age of 60 than those living between the ages of 0 to 15. And this means the population or the demographic of the world is increasingly includes more older people. The implications of this is the number of people living with age-related chronic conditions such as dementia and stroke would increase. And so the need for us to deliver care facilities that cater for the needs of people living with these conditions will increase. One of the key areas where we can support people living at an elderly age or living with various health conditions that require support is through the way we design the built environment. Research indicates that design of the built environment does have an impact on physical health, psychological health, social relationships, and as well as cognitive functioning of people, and most importantly, elderly people. Healthcare facility design is also known to influence outcomes and inpatient experience. As a result, there is a need for more thoughtful approaches towards designing our healthcare facilities. And one of the ways in which we can improve outcome is actually involving the users in the design process. And so participatory design does equate to better outcomes from research evidence. And one of the ways in which we can ensure participatory design within the elderly care scenario is to actually get some of the elderly users of the facilities to have some input during the design process. So in order for us to be able to attain elderly centered design, we need participation, and such elderly centered design would help us in improving the user experience of people who would require the building to support them in various functions, especially when they've got impairments as a result of illness. As a result of this background, the research sought to develop tools that enhance the level of participation of end users in care facility design. This brings us to the aim of our research. So basically, in our research team, a lot of the work we do is around virtual reality and immersive technologies. And so basically, what we try to do in this research context was to explore whether or not user involvement in care facility design could help improve outcomes. And then secondly, we wanted to understand whether we could use virtual reality to help facilitate such participatory design, and how these virtual reality tools should be designed in order to achieve better outcomes. And so overall, the aim of the study was to enhance elderly user participation in healthcare facility design through interactive virtual reality. In terms of the methodology, this was delivered in two main phases: the development of the VR application for participatory design, as well as the testing of the application. In terms of the development of the application, we firstly developed 3D models using Autodesk Revit, and the 3D models was mainly for the interior design of a patient room or a room for someone who requires assistive living. And then 3D objects of the furniture as well as other features of the interior design were also developed. This was then transformed into a virtual reality simulation using a gaming engine, Unity 3D. And then we now developed user interface as well as interactivity within the model using C# programming. The principles was basically for the user to be able to reconfigure the design as well as import different fixtures and equipment that could be used for assistive living, such as patient beds or wheelchairs or any railings for physical support. In the application, they could see the implications of placing these equipment around the building and how that affects things such as the amount of space left for walking, as well as space needed for any other function within the space. Having developed this, we then tested how it works in terms of its user friendliness and in terms of its suitability for participatory design in the second phase by interviewing a group of 7 experts, including nurses, caregivers, architects, and designers, as well as elderly care consultants. In the next slide, we would explain what we found after this experiment. Having developed the application and tested it, we then sought to primarily understand the usefulness of this application, its applicability in the context of elderly users, as well as identify any needs for modification to make it more user friendly or effective. The reason why we trialed this among carers and expect rather than the old people itself is quite obvious. It's because we want to develop a fully functional and safe application before we actually use it among the elderly who could be classed as vulnerable people. So the feedback we got actually led us to do some improvements in the tool, but also it also led us to propose some improvements for future tools. In terms of the findings, the key findings related to safety, and this included the inability for elderly users to navigate the virtual space themselves because they are fully immersed, and there's the risk that they might run into physical objects around them. The other was about loneliness in the virtual space when they are immersed alone, and especially when they have challenges with the user interface. This could be quite isolating and difficult for them to be able to resolve. As a result of these two, some of the recommendations was for us to use voice activated commands that requires people to talk rather than interact with the user interface with their hand, because the hand gestures that the leap motion sensor we use recognize, for people without any disability that would be easy, but for older people who might have disabilities that impair their hand movement and the like, that might be difficult. The other thing was rather than doing a full virtual walkthrough, was for us to use teleportation functions that makes people sit in one place and then move around the virtual space. So for an elderly person, they could sit in a chair and still be able to navigate. So these were subsequently built into our application. Again, the other recommendation was for multi-user VR experience, which means not only one person could do the design review, but 2 people could do it whilst the other appeared to the other user as an avatar, but they could still talk to each other in the same space. So again, for an old person who's having challenges, someone who's more able-bodied could actually be part of the experience and handle the user interface and drive navigation through the virtual model or the design space rather than the elderly person himself doing it. So these were some of the key factors that came up, and they were mainly safety related. And like I said, so we did address some of it in the current application, but also look forward to addressing this in future developments. In conclusion, the proposed VR system can support user involvement in care facility design. All of our participants agreed that this was a very useful application and quite intuitive, in addition to raising some of the safety concerns. One of the things that we think could be explored in terms of future studies is to use less immersive technology. So, for instance, technologies such as mixed reality that could allow users to still see the external environment whilst they are exploring or reviewing design. The downside of this is that most mixed reality experiences do not have the same quality of visuals and therefore reduces the level of realism of of the experience. But then future research could look at how these could be tailored for the elderly user, first of all guaranteeing their safety, but secondly also addressing some of the realism issues. In addition to what was already mentioned in the findings, most studies of this nature should look more at teleportation for navigation rather than normal virtual walkthroughs that actually require people to walk physically whilst they are using a VR headset. And also multi-user functions, as also earlier mentioned, would be relevant in the elderly care scenarios to get able-bodied people to assist in doing the virtual simulations, walkthrough, and design reviews. So this is what generally came out of the work, which we believe was quite successful in the sense that all participants agreed that it's a useful VR application, and this could be used more within construction and even beyond the elderly care scenario for general design coordination and user participation tasks. So thank you very much for listening. We look forward to hearing from you in terms of comments, questions, or other contributions. Thank you.